Welcome back to another HVAC Engineering-Techie training video. Remember, these training videos are technical in nature and are intended to help you with your career. So today's lesson is HVAC outside air package AC units. One thing that a package unit doesn't do well is 100% outside air. So this video is showing you how that's done and how we use those. So this could be helpful to you. So remember that this channel talks all things HVAC, from engineering design, construction, equipment, systems, test and balance, controls, efficiency, and performance. So one thing I'd like to ask you to do, a big favor for me, if you would become a subscribing member if you're not already. All you have to do is click that black subscribe button down below and give me a thumbs up if you like the videos. It's absolutely free, costs you nothing, it's painless for you. But it really helps me. What happens is Google uses that data to evaluate these videos, which actually keeps me on the air. So I really appreciate it. These are a lot of work, and I would appreciate you helping me out with that. All right, let's get started on HVAC outside air package AC units. Thanks. So we're going to start talking now about outside air systems. And these are package units that are designed to treat outside air and put that outside air into other package units that are serving the building. Now this is fairly easy to do on chill water and hot water, but it's very difficult to do on package systems. So that's why we're talking about it separately. Okay, energy recovery units. These are simple systems that have heat exchangers inside them. It could be a heat wheel or it could be a heat exchanger. And basically what happens is the exhaust air comes out, goes through the unit this direction and is exhausted, and the outside air comes in this side, it goes to the heat exchanger and goes to the building as makeup air. So the way these work, you'll notice there's filters and dampers. These are isolation dampers to isolate the exhaust stream from the building and isolate the fresh air system from the building. And they have filters on both sides. And the reason is the exhaust air can have a lot of lint and a lot of dust. So they want to take it out. We don't want to clog the heat exchanger with that dust. And of course outside air needs a filter because it can have dust and dirt coming in from the outside. Now the condition of what kind of heat exchanger you use here, there's several available. This one shows a dry bulb temperature heat exchanger. So it will take the heat from the exhaust air and move it over to the inlet air. So if it's in the summer mode and the air is hot, it'll take this cooler exhaust air and cool the outside air off. If it's wintertime, when it's cold outside air, it'll take the heat of the exhaust and warm up the outside air as it goes through. So it depends on what the system is. Now these normally have, the simple ones have starters on them, and it can run, and they have that to run. Now you could do this variable volume, but normally on these package units we don't have that. These are real simple systems. So we normally put a supply sensor in the exhaust, supply sensor in the makeup, and a supply sensor in the makeup air. And with these three sensors, we can tell the energy exchange within this unit. So the sequence is the exhaust and outside air fan should be on, and the outside air and the exhaust air dampers open when the unit is scheduled in the occupied mode. Monitor the outside air inlet and outlet, the outside air inlet and outlet temperatures, exhaust inlet temperature, and fan status for both fans. Okay, now this is a dedicated outside air unit called a DOAS, and it's basically a bigger unit. This one happens to have a heat wheel for heat exchange in there. There is a little bit of a problem because it's an air conditioning unit. Air conditioning units cannot withstand very high ambient temperatures for 100% outside air flow. So if they're regular air conditioning on a building and they have 20% outside airflow, that'll work because the mixed air temperature is never that hot. But if you get a mixed air temperature that's going to be 110 degrees, you're going to have a problem because you can't gas a unit for 30 degrees outside and 115 degree outside if we have 100% outside air. We have a unit for that, but that's not this one. So that's why they put a heat exchanger in here, taking and trimming off the outside air with exhaust air so that we can get it colder. So this way this works. This has a return flow that comes up here, goes across filters, goes across a heat wheel, and is exhausted out of the building. In this case, we have inlet air coming in here, going through the filter bank, through the heat wheel, through an air conditioning coil, through a heat strip, and out to the building. And this ductwork out to the building goes and has a bunch of dampers that are inlet dampers to other air conditioning systems, and these are their outside air systems. These could be just dampers controlled by that package unit, or these could actually be VAV boxes that are set up to be constant volume, so that gives it that constant volume outside air to the unit. So these normally have VFDs here and VFDs here to the supply fan and exhaust fan. They, of course, have a refrigerant circuit, and these normally have hot gas bypass so they can run when it's colder out there. The supply and return fan, the sequence is supply and return fan, the heat wheel shall run, and the exhaust air and outside air isolation dampers will be open anytime the system is in the occupied mode. Now, this is just like that unit we looked before, that economizer deal we just looked at. But this acts bigger. This got an air conditioning circuit in, where the other one was just air and a heat exchanger. This one is a bigger unit. Stage the compressor and the heat strip stages to maintain supply air temperature set point. Initially set point should be 78 degrees. So since these are makeup for other package units, the intention is to trim off the outside air, so we're supplying basically return air conditions to the unit. So the unit doesn't see this outside air load. It's only seeing the building load, which gives them a little bit better and allows us to do all that complicated stuff all in one unit. So if we want dehumidification mode, we can dehumidify this air right here. So these other units that are getting the air don't have to do that. We'll do it all here. If any room humidity rises above 60%, begin a dehumidification mode. Control the compressors from the leaving coil cooling temperature sensor with a set point of 50 degrees. Stage electric heater to maintain the supply air temperature set point. Reset the cold deck temperature set point to maintain an average room humidity of 50%. If the room humidity drops below 45%, disable the dehumidification mode. So basically we're taking this coil and dropping the temperature down, wringing the moisture out, then reheating the air back up to be the temperature they want for the inlet air. And of course we're using the heat wheel to capture all of that as we can here. And the refrigerant circuit is actually inputting that here. Now you'll notice that this is also going to have an enthalpy control. And let's go look at it. The supply fan speed should be modulated to maintain supply air pressure set point, just like any other VAV system. Modulate the outside air damper to maintain the building pressure. Monitor supply air temp, entering and leaving exhaust heat wheel, air temp, and supply air and exhaust air fan status. So remember, these systems out here might be VAV or they might not. They might be constant volume, but it doesn't make any difference, because we're actually doing this outside air conditioning is providing a constant flow of air into the space. But as these dampers might change for whatever reason, we can do VAV. And remember, this is not trying to do economization. We don't have a big enough system. This system is just big enough for the outside air requirements, not full economizers of these air handling units. That would not be good to try to do. We have humidity in here because we're trying to dehumidify. So we're going to dehumidify off room conditions. We have status conditions to see what's going on. Now this is a simple makeup air unit. This would be used for a kitchen or any other space where you have a whole bunch of air exiting the building for whatever reason. So these are normally, the normal system don't have air conditioning because of that high temperature ambient condition. They don't have heat exchangers either. Normally, in anywhere else but the deep south, they will have an air washer in here which is able, using evaporation, is able to drop the temperature of the air, and that becomes the cooling cycle. And then we have a gas furnace in this one which will provide the heating to the space. So it's got a blower, it's got an isolation damper, filters, an air washer, a gas heater, and a blower to the space, and a DDC system used for makeup for kitchens and process fume hoods. No DX refrigeration due to high ambient temperatures. Evaporator cooler section, gas heater section, very energy efficient. Doesn't work very good if you got a high humidity. Very efficient on energy, not very good for space. If you have high humidity, it's not going to provide you much cooling. The supply fan shall run
and the isolation damper open anytime the system is in the occupied mode. Start, stop the evaporator cooler pump and modulate the heater gas valve to maintain room temperature set point. Monitor the room temperature and supply air and the supply air temperature. Okay, here's a makeup air AC unit. Now this is a 100% makeup air unit. It's just an AC unit. So it has to be sized for an environment that can handle this. So basically it's a 100% outside air unit used for exhaust makeup air for kitchens and process fume hoods. DX refrigeration will only perform with ambient temperatures below 100 degrees. So you can gas the system for 100 degrees because we're not trying to get real cold air. We're trying to just get enough to appease the load inside. So basically it's an air conditioner that brings the air in through the filter, through the cooling coil, through a gas heater, and to the space. We have a normal DDC override in this thing. So we have a room sensor and a supply air sensor. And a fan control. That's pretty much it. Refrigerator system with hot gas bypass. It has hot gas bypass, so it can do its job when it's colder temperature. A gas heater section. The supply fan should run, and the isolation damper should be open anytime the system is in the occupied mode. Start, stop the compressor. Stage the heater gas valve to maintain supply air temperature set point. Monitor room temperature and supply air temperature. One of the reasons these can work is we can gas this such that it can handle that higher temperature. It just won't be super efficient. If you're trying to do 68 degree air, it won't do that. It's going to be a problem. Maybe 70 degree air, no problem, because it's gassed with the higher temperatures. So you can do that. And they use these a lot in areas where they don't have real high ambient. There's a lot of places that have high humidity, have 95 degrees as the high temperature, so you can use those. So now we'll talk about a variable flow makeup air AC unit. So basically this is a unit that has 4 different segmented cooling coils, 4 compressor circuits, and variable speed fans to do the system. So what happens is we have these isolation phase and bypass dampers basically. So we can open one damper and limit it to just one coil that's sized correctly for that one coil load. So when we have a load out there, in this building, we have DDC, and we can control each of those separately. And we'll go through the sequence to show how that works. So basically, we can tune this refrigerator circuit for just 25% flow, like a full package unit at full flow at that one system. And then we can keep increasing the capacity as we go up or down. We can do that. So we have variable speed drive on the forward curve. It's 100% outside air, variable flow, used for variable flow makeup applications, segmented cooling coils with phase and bypass dampers, multiple cooling circuits, refrigeration system with hot gas bypass, electric heater section, probably on an SCR control so we can generate how much heat we put into there. Here's the sequence. The supply fan shall run and the outside air damper shall open anytime the system is in the occupied mode. Start the fans at 25% load. Modulate fans to maintain room pressure set point of 0.02 inches. Upon a call for cooling, the fan face damper number 1 and open the circuit solenoid valve. Hot gas valve shall modulate to maintain coil low temperature. Modulate the electric heater SCR to maintain the supply air duct heating set point. Now that's the first circuit. So we got first circuit operating. Okay, as the outside air modulates past 30%, open number 2 face damper and open the circuit solenoid. If the outside air damper drops below 25%, close number 2 face damper and close the circuit solenoid. As the outside air modulates past 60%, open the supply air number 3 face damper and open the circuit set point. If the outside air drops below 50%, close number 3 face damper and close the circuit solenoid. As the outside air modulates past 80%, open the number 4 face damper and open the circuit solenoid. Hot gas valve shall modulate to maintain coil low temperature. If the outside air drops below 75%, close number 4 face damper and close the circuit solenoid. If the room humidity rises above 55%, control the circuit solenoid from the leaving coil temperature sensor to 55 degrees. When the room humidity drops below 45%, return control to the supply air temperature sensor. Monitor the supply air temperature, supply humidity, room pressure, and room humidity. So these systems work. They're expensive because they have a whole lot of systems in them. They have 4 separate refrigerator circuits, 4 compressors, for VFDs on the fans, and they can provide this to base. Like I said, the one I used was on a marijuana grow room because they needed a whole bunch of outside air at different times of the process. I don't know what that is, but I did help them with this unit. So that basically shows you the variable flow makeup AC unit. So these were kind of interesting systems. We don't use a lot of AC makeup air units, only because normally on a package system, we let outside air be at each system. But we do have some jobs that have a lot of AC VAV units, which could use an outside air system. But this is for a special dedicated process, and hopefully you found that interesting. I really appreciate you being a subscriber. That helps me a lot. Thank you. I appreciate you watching the video. Please share with your friends. Let them know what's out there. And I hope you have a great day. And I'll catch you on the next one. Thank you.